Today I will be talking about the original process. Emilio Avogadro's laboratory environment reflected the simplicity and ingenuity of early 19th century scientific work. His lab, likely located at University of Turin in Italy, where he taught physics, was modest yet functional. It was characterized by wooden benches, open shelves filled with glassware and reagents, and natural light streaming in through large windows. There were no electrical devices at the time. Instead, Avogadro relied on manual and thermal energy sources such as flames, mercury columns to perform his studies. His workspace was quiet and orderly, ideal for the careful observation and reasoning that defined his scientific approach. His difficulties. The biggest hurdle Avogadro faced was conceptual rather than experimental, convincing others to accept his idea that equal volumes of gases contain equal numbers of molecules. Since atomic theory was still controversial, his hypothesis initially lacked experimental validation and was not widely accepted until decades later. Avogadro's discovery was intentional rather than accidental. Unlike some discoveries that happened by chance, Avogadro's law was the product of careful reasoning to theoretical deduction. At the time Avogadro's work, the immediate practical benefits of his discovery were not obvious. His proposal was primarily intended to help scientists, chemists, and physicists better understand the composition of behavior gases. The discovery of Avogadro's law in 1811 brought both immediate theoretical benefits and laid the foundation for long-term scientific advancements. Although its practical impact was not instantly recognized, Avogadro's insight provided a powerful new way to understand the relationship between gas volume and molecular quantity, influencing chemistry, physics, and later entirely new scientific disciplines. Modern equipment is highly precise and designed to minimize human error in experiments involving gas laws and molecular quantities. Scientists use sophisticated instruments to measure variables that Avogadro could only theorize about. His modern differences. Digital instrumentation. Experiments are now conducted using sensors and computer-controlled systems that automatically collect and record precise measurements of pressure, temperature, and gas volume. Automation and robotics. Robotic systems can perform repetitive and hazardous tasks, increasing safety and productivity in research labs. His modern benefits. Medicine biotechnology. Understanding molecular interactions has enabled the development of drug design, vaccines, and genetic engineering. Molecular modeling helps predict how drugs will interact with cells, making treatment safer and more effective. The future expectations. Looking forward, scientists are likely to pursue research and goes beyond the atomic and molecular scale, focusing on areas such as quantum chemistry, molecular engineering, synthetic biology, and sustainable technologies. One major goal is the precise control of molecules and atoms to create materials, medicines, and devices with properties tailored for specific needs. And that is all I have today.
This is Gavin Edwards with Part C of Avogadro's Law. For the original lab environment, since Avogadro was a chairman and taught at the University of Turin in Italy, it's safe to assume that there's almost no information on what their labs looked like. But what I can conjure, since I don't have any documentation, that it would have been a well-lit room with many windows, wooden benches lined throughout the room, and there'd be many flasks, bulbs, tongs, and cabinets, and other things. There wasn't much then. Original lab equipment. The equipment he most likely had were sealed gas tubes, thermometers, barometers, graduated cylinders, balance scales, along with other items or other equipment. He did not use one specific procedure, but used work of previous scientists such as Gay-Lussac, Gay-Lussac on the combination of ratios of gases, Dalton's theory on the visibility of atoms. Dalton made a mistake with his thinking, and Avogadro filled in this space and corrected his work by further investigating gases and molecules with the hypothesis that equal volumes of different gases containing equal number of molecules when under the same temperature and pressure conditions. Original difficulties, initial hurdles. The atomic theory was not fully accepted because Dalton's atomic theory was still new to the scene and was not widely accepted. From Dalton, the terms molecule to atom wasn't differed accurately as it is now. He also had no direct way to detect molecules. He often referred to his logical reasoning, such as the people of the time, as philosophers, since he didn't have sophisticated equipment. Safety issues. Most likely had limited ventilation due to lack of AC, so they had open windows around gases in the room. Open flames were probably present, especially if it's in the wintertime, and no personal protection equipment was really around, and they didn't have modern safety equipment that didn't have safety regulations and building codes like we do. They had like lab coats and goggles and stuff. Information processing. They didn't have computers or the internet like we have today. They published papers or journals, which took a while to circulate to other scientists, which they had to go over and work out some of the problems and information themselves. Not all the terms were completely solidified in the scientific community. Not everyone widely understands English like we do, or at the time, French and Italian for him and his time. Original motivation, the initial goals. He initially wanted to do whatever physicist wants to do. Answer question and uncover previous mistakes from the past and learn from them and to make advancements. The discovery was intentional. He knew Dalton's theory needed to be refined and make it better, and the discovery was not accidental. We don't know his true intentions, but we know he did want to discover the truth because he had been in law, philosophy. He was a philosopher at one time, and so he was a man on the search for truth. Immediate benefits. Well, there weren't immediate benefits for other fields because it wasn't accepted till really after his death, which I believe is around 50 years after. It became more accepted. It allowed more accurate understanding of how gases and molecules work. Also helped clarify the difference between atoms and molecules. Advancements in the field. It helped develop a more accurate atomic theory. Helped understand it's H2O and not HO from Dalton. Uses stoichiometry for more accurate calculations using moles. Modern processes. In a modern lab environment, it's very lit with ceiling, lights, AC, more safety equipment, computers. Modern lab equipment, PPE such as closed-toed shoes, pants, gloves, shirt, safety goggles, fume hood, eye wash, controlled heating sources, digital balances, gas syringes, batteries, spectrometers, barometers, collection tubes, pressure sensors, and sealed reaction flasks, etc. A modern experiment procedure, measure magnesium strip, fill a gas tube with HCl, hydrochloric acid, suspend a magnesium strip over hydrochloric acid, set up a gas tube collection system, release magnesium strip into the acid, measure the gas volume, calculate moles of H2, apply the ideals gas law. No. Modern advancements. We can use digital sensors to measure gas, pressure, temperature, and volume accurately. Can use inhibitors if needed. Can use computers to simulate gas behavior at the molecular level. And Avogadro's constant 61022 by 10 to the 23rd is extremely accurate. Modern protection. Lab now has more protective equipment, fume hoods, PPE, eye wash stations, fire extinguisher, ventilation systems. Modern information, digital pressure sensors, temperature probes, electrical gas sensors, and passive capstone. Information processing, data is stored in computers, calculations with P, pressure, volume equals M to RT, are done automatically through calculations or whatever it's called. The results can be shared online, stored in databases, and spreadsheets for cross-examination from other scientists. Modern benefits of the research. The mole used in stoichiometry to get more accurate calculations in chemical reactions. Used in ideal gas law, which is used in calculations, chemistry, physics, and medicine. Avogadro's constant helps predict and control gas behavior for fuel systems, which is used in almost everything that requires gas running through its system. Other fields: pharmaceuticals, engineering, environmental science, nanotechnology, and physics. Technology created. Breathalyzers use gas laws to determine alcohol from breath volume. Gas storage and transportation used very widely in pipelines, such as industries and residential use. And airbags also use Avogadro's law and ideal gas law to deploy, as well as respirators and ventilators. Future expectations. I hope that the predictions and simulations become more increasingly accurate, so we can get better help for medicine, everything like that. Everyone wants to be more healthy. Potential benefits: that when the accuracy becomes more precise over time, the pharmaceuticals, physics, and everything else that uses applications of Avogadro's law can help benefit the world by being more accurate. Thank you.